Alright, so now we're going to be working on our first positioning property, position static. So once again, all elements have this value. All elements have their position property are all set to static by default. So you don't even need to type it in because it already is set to static by default. Basically, static means that it follows the flow and it follows the order, the structure of the document. They are all coordinated. They're all coordinated basically. They're all structured. They're all organized. There's a specific sequence. So that is what static does. However, the limit, of course, is you cannot use an offset value where you can't move it or make it go against the document flow. So for example, if we used top value and we want to set the element to a value that is higher than originally is. For example, if we wanted to set the top value, so we wanted to set to a higher value to maybe, and a high value would mean a lower value. So let's say 10 pixels, you can see that it doesn't move. It doesn't move at all. So that is an advantage, a disadvantage. So we're going to remove that. And now our next positioning value is relative. So what relative means in this case is the element's position is based off of the original position of the element. So it is also like static, basically. It follows the document flow, the document structure, and how everything is structured. However, this time we can use offset values. We can use values that move the element to a different position than it originally is supposed to be kept at, while still being in the document, while still following the rules and structure of the document. For example, the element will still be a child of list item because, the span element is a child of list item. So it will still be a child of a list item, unlike we'll see later with absolute and fixed. So we can set the top value to a value higher than it is, which is -10 pixels. So you can see that it has gone higher than its original, but it doesn't disrupt anything. Nothing is disrupted. So that is a good advantage. However, just like before, just like with translate, the space that it originally occupied is still there. The document still reserves that space for the element, even though we don't want it. So for example, if we set a lower value to, let's go with 30 or 25 pixels, so it is towards the right corner. However, still the space is still occupied, reserved, and we don't want that. So we can't use position relative in this case. So the next positioning property value is absolute. So position absolute, now you can see the position of the element has now changed. Position absolute is unlike position static and position relative. It takes the element out of the document flow. It takes the element out of the document structure. So right now, the list item, which you can see in our HTML file, is the parent element of the red circle, of the span element. But now you can see the space that was reserved for the list for the counter is no longer there. The list item, or the parent element, which is the list item, only considers the SVG and is only reserved space for the SVG. So you can see the SVG behind there. So the space is still reserved for that. But the space that we had for the span element is no longer there. So we're kind of one step ahead to where we want to be. So now it's as if the span element is invisible. It's still there. Technically, it is there. And that's why you can see that the position of the element it's not somewhere random. It's specifically where it's meant to be, but the parent element ignores it. It kind of like abandoned it. So basically what position absolute does is it looks for the nearest parent element, the nearest ancestor. So ancestor being like, it could be the parent or the grandparent or the great-great-grandparent, the great-great-great-grandparent, all the way back to body, the body HTML tag element. So it looks for the nearest ancestor that has a position value that is not set to static. So it could either be absolute itself, it could be sticky, it could be relative, it could be fixed, but not static, except for static. Static does not count. And basically it will be the positioning that we set it to will be relative or will be based off of the boundaries of that parent element that has that position, whether it be relative, absolute, fixed, sticky. So for example, it would check only parents, no siblings. So for example, this is the span element. So the parent would be the element that it is contained by, which is this item. So it checks if it has position, either or any positioning value that is not static. If it doesn't, it moves on to check for UL. Doesn't, then it checks for div nav settings. Doesn't, then it skips all the way to the parent of this div. So it doesn't even check the siblings, but the parent of this would be here, ID navbar. It checks, doesn't have, then it checks nav, doesn't have, then it checks body. And so it just basically looks for the nearest ancestor, the nearest parent element that has any of the positions other than static. And if it doesn't, then it will just be, the positioning will just be based off of the viewport. So right now the browser has set the position of the span element. The browser has just looked for where it's supposed to be and has set it there. So right now we can set the positioning first. And this time, actually, let's use bottom. So we want it to be at the bottom of the container. So we're going to set it to bottom 0 and then left value to 0. So right now, as you can see, the positioning of where we are, the positioning of the element is basing off of the navigation element. And that's because we've added position sticky so that, we could scroll down and the nav element could stay at a particular viewport position, which is right here at the top. So it stays there as we scroll down. So we used position sticky. It has set the positioning based off of the nav element's boundaries, width and height. So the width and height of the navigation bar is here to here, here to here. So we set the bottom value to be 0. So the bottom of the element is touching the bottom of the navigation bar. And we've also set the left value to 0. So the left side of the element is touching the left side of the navigation bar. So if we try and remove this, we can see that, it is now somewhere over here down below. So now the element's position has been based off of the full document because no other parent element has a position that is not static. All of these elements have been set to position static, and now this positioning value is now set to the default, which is static. So now the positioning of the element has been based off of the viewport dimensions. So the viewport being like from here to here. So basically it's kind of like how you see videos and frames. Maybe a video has obviously multiple frames, and that can run per second. So a viewport, I would basically describe that as a frame of a website. So this is one frame of a website. This is another frame. This is another frame. This is another frame. This is another frame. They're just scrolling slowly. So I would say viewport is just basically like a frame of a website, the way you see a frame of a video. However, it's not following us. So as we scroll down, it doesn't follow us because we've set it to absolute. However, we can also set it to, if we wanted to follow us, if we wanted the element to, stay at the bottom as we scroll down, then we can use a different property, which is fixed. So as you can see, when we scroll down, it stays at the bottom left side. So left bottom corner as we scroll down. So its positioning is based off of the typical viewport's positioning, which is from here to here. And widthwise is from here to here. So position fixed is pretty much like position absolute. It basically it gets out of the document flow. The parent element has abandoned it completely, so it no longer the parent element has no longer reserved a space for the element. It has ignored it completely, and the positioning that we set it to, whatever offset value that we set it to, the element will be positioned there, and it will stay there. Even as we scroll down, it will stay there. So basically, it's positioned according to the viewport's dimensions. So for example, we can also set bottom to be 50%. So the bottom of the element is at 50% of the viewport, at the viewport height. So from here to here. So now it's at 50%. And we can also set it to the middle. If you want to set it to the middle, so we can set this to 50%, and the left part of the element is now positioned centered to it's positioned towards the center of the viewport's dimension. So the viewport's width being from here to here, so now it is towards the middle, towards the center, around approximately. Now we're going to be using position absolute pretty soon, but now let's introduce our final positioning value, sticky. So we're going to head back to position absolute in a minute so that we can properly set our elements. So now for position sticky, as you can see, we have used it earlier for our navigation bar so that when we scroll down, the user could still access the navigation bar, so they don't have to scroll up if they were scrolling down. It provides a more convenient user experience. So we're going to put it back to navigation bar. All right, so now you can see that the position is set to sticky. All right, so position sticky is like a encapsulation of position relative, yet also position fixed or position absolute, but to a certain extent, and with its own twist. So it's kind of like position relative because the document acknowledges that the navigation bar exists, that it is a part of it, that it is a part of the of the family. Basically, it hasn't abandoned it like it would for position absolute. Position absolute would completely abandon the document or the parent element would abandon the element with position absolute However, if we set it to position sticky, the parent element does not abandon it. It considers it as its child, as its family. So for example, if we set this value to 50%, so as you can see, it has set itself to 50% of the viewport's dimensions. So when we scroll up and down, it kind of acts like position fixed. But as you can see here, this space is still reserved for the navigation bar because the document, once again, the parent element of nav, which is just the document body, acknowledges that it is an element, that it is its child. But it also acts like position fixed because it positions the element, whatever offset value that we've set, it positions and it latches into based off of the viewport. Even as we scroll down, we still see that it is at 50% of the viewport's dimensions. If we set it to a random value, like say 10 pixels, so as you can see, when we set it to 10 pixels, you can see there's a little spacing, and as we scroll down, it stays right there. Unlike position relative, where if we set it to 10 pixels below where it's originally supposed to be, when we scroll down, it will disappear. We will no longer see it. But for position sticky, it sticks onto this particular position that we've set it to. So it bases the positioning based off of the viewport's dimensions once again. However, for example, if we set it to bottom 0, we can see that it's not following us. It's not being repositioned towards the bottom at all. It stays at top. And the reason is because nav is a child, okay? And then another child, a child of body. And then another child of body is div, which is a sibling to nav. So nav, because it still follows with position sticky, it still follows the document's flow. It still follows the document's structure. And we can consider nav to be the firstborn, and we can consider main div to be the secondborn. So nav will always be the firstborn. So it will always be towards the top. And then the secondborn is towards the bottom. So using bottom 0, trying to force it to be towards the bottom, trying to force nav element's bottom to be towards the bottom of the viewport's dimensions will not work, because the natural position of nav is towards the top. It's the firstborn, so it should always stay on top. However, this can work if we move nav element to be the secondborn, to be born after the other element here. So if we move it here, now we can see that because it is the lastborn, or it is the secondborn, we can see that we're able to scroll down. So, and that is because, and it's lashing towards the bottom because this is the last element in the body. This is the last born of the body, which is the parent. If we added another element to be below the navigation bar, to be the last born, so then nav becomes the middle child. So for example, we can copy this and we can paste this. So now it's become the middle child. So it's no longer the last born. So as you can see here, it latches towards the bottom right until we reach towards the last born's side. So the last born takes this space from here where my mouse is until the bottom. So that's the last child's dimensions. And you can see that the nav no longer latches towards the bottom of the viewport because it is no longer the last, because it is before this element. It is before the main. So it cannot be below. We cannot force it to be below. I mean, it does not come after this element. It becomes before. So it can't be at the bottom. However, it can be below this one because the nav comes, for now, the nav comes after this side of the element, which we have specified here at the top. It comes after. So it can stay at the bottom just for a little while until we come to the true last born, because this one is born before, so it has to stay before, which is its true original nature. So we cannot try and change nature here. So now we can set it to top 0, and we'll also remove the extra. Actually, we'll just remove this element here, and we already have our main element below. So now when we try to scroll down, because it is the firstborn, it stays on top. It has the right to stay on top. But if we add an element, once again, to be born or to be placed, to be born before the nav element, then this element will be seen first because of how the structure of the document is. We need to see this element first, and then the document is like, we can consider keeping this towards the top, but only if it's meant to be, only if all the other siblings are below it. So just to give you an example now, the nav is no longer sticking towards the top. We are forced to see this element first because it's the firstborn. So now when we try to scroll down, and if we lengthen the size of this, so let's say let's just use inline style just temporarily, and let's set the height to be around 100 viewport height. And now when we try to scroll down, we can see that the navigation bar sticks towards the top. However, when we scroll up to where it's the firstborn, the element, so any element that is before the navigation bar will not stick. So now that we have knowledge about position absolute, position fixed, position sticky, position relative, and position static, we're able to determine how we can set this towards the right corner of the element. So there's actually two ways of doing this, but one is not recommended at all. So we can scroll down all the way to here where we have designed or selected our saved count element. All right, so now what we can do is we can remove these two values, these offset values, and we can see that the span elements are basically where they are meant to be, but the parent has abandoned them, but browser has considered their original positions where they're supposed to be, basically. However, when we set an offset value, any positioning that we add will be based off of the viewport. So if we set the value to top 0 and left 0, it should be towards the left corner. And same thing, if we move it towards the right, it should be towards the right corner, bottom, etc. So what we can do with position fixed, because position fixed basically it causes the parent element to abandon it, you see that there's no space reserved. So in this case, we can now comfortably use transform and use translate, and we can set the x and y value. First value should be x value. So let's say I believe it was around 25 pixels that we used earlier, and then a y value, which would be maybe -8 pixels. So let's see how that goes. Okay, so it may be a little too far, so let's set it to 15, and 8, 10 should be fine. So we can see that it is towards the right corner, and we're able to use transform. Earlier, we could not do this. We could not use this because the space was reserved and it didn't look pretty. So with position fixed, because the parent has abandoned it, doesn't reserve any spacing. But this is not recommended at all, as when we use position fixed, you can see that the browser is the one that has to calculate where because there's no offset value being set, so it has to just put a random estimation as to where it's meant to be. So we're giving browser more work when we don't need to give the browser more work as to calculate where the value is supposed to be, because we're not using offset values, we're not using top, left, right, we're just using transform, translate. So instead we can use position absolute, which also it causes the parent element not to reserve any spacing for the element that has position absolute. So the parent element has abandoned the red circle, the count. So there's no reserved spacing left here. Now, as we said earlier, any parent element or ancestor that has a position value that is not static, so any other of the 4 other values except for static, it will basically base its positioning there. So we can see that right now we have position sticky in a navigation bar. So it will be the limits or where it's going to be positioned, how it's going to be positioned will be based off of the nav element. So if we set top 0, left 0, we should see it towards the bottom, towards the top, the corner of the navigation bar. If we set bottom to 0, we can see it is towards the bottom corner of navigation element. So it's not like position fixed where it just bases off of the full viewport height and width, but position absolute allows us to base the positioning a value based off of the nearest parent element that has a position value that is not static. However, we want the positioning to be based off of the parent element of this element of the counter. And the parent element, which size is from here to here, is our list item. As we see when we scroll down, we can see that the parent element of saves count is here. And we basically want the positioning to be based inside the parent element. So we can see that the parent element now has position relative. The limits, the boundaries are now based off of the parent element list item. It's no longer based off of the nav element, because nav element still has position sticky. But as I said earlier, the nearest element, which has position which is not static, it will base its positioning off of that. So now the nearest parent element has become list item, which has a position that is not static. So we can see that we've set it towards the bottom. So we're actually going to use top because we want it to be at a higher value. And we can go with, for example, -8 pixels. So now it is towards the top. So the lower the value, the higher the element will go. And then for left, we can set it to a higher value. So if we wanted it to be further away from the left, then we have to have a higher value. So we can set it to, for example, 10 pixels. So it's 10 pixels away from the left. So let's go with 8 pixels, and let's also decrease the value. We want it to be slightly lower. So now you can see it is perfectly towards the right corner of the SVG.